Hi, I'm Paige Leverin. I'm from the College and Career Readiness Program at Visalia Unified, and welcome to our first Ignite Your Curiosity Elementary Edition. We're going to do this monthly to go over different areas of STEM and have you join us to have some fun along the way. We're also going to tie in some college career ideas that go along with STEM. During tonight's presentation, watch your chat box. We are going to have different websites that you might want to explore later pop up in that chat box. So go ahead and copy and paste those as they come up. We are joined tonight with Jim Billingsley. Jim Billingsley is a coordinator for the curriculum in math and science for Visalia Unified. And so with that, I want to welcome Jim Billingsley. Thank you.
Hello and welcome to tonight. We are very excited to have our first ever STEM Ignite Your Curiosity night. I am the STEM Science, Technology, Engineering, Math Coordinator for Visalia Unified. And so I'm really looking forward to tonight where we can really explore the sciences and kind of looking at those college and those career choices that we can make looking in the STEM careers. So with that, I'm going to first introduce Ann Welker. She is a science teacher at Ridgeview. She is going to do a few science demonstrations for us tonight. And then that'll be followed by Ryan Chung. He is a former Visalia Unified student who will kind of share his experiences with STEM. And so with that, I'd like to introduce Ann Welker to the demonstration.
Hello. So like Mr. Billingsley said, I am Miss Welker and I'm from Ridgeview Middle School. So I ended up going to Cal Poly in San Luis Obispo and I majored in biology. So science has been near and dear to my heart for a long time. Now, today we are going to be looking at a few demos and they're all going to be relating to Newton's laws of motion. Isaac Newton was a scientist and he lived in England. He lived about 300 years ago and came up with 3 very important laws of motion. Now, his first law of motion has to do with objects at rest, staying at rest. So you can see I have my place settings here, but you know what? I really do not like my tablecloth. So I need to get rid of it. So I'm just going to try to do this the quickest, easiest way possible. And let's see if I can do this. So there we go. So if you have an object at rest, like my dishes here, they will stay at rest unless you have an unbalanced force. Now in our case, this tablecloth had very low friction. So friction is the force between 2 moving objects that are moving against each other. So if you take your hands together and you rub them, you start to feel heat. And that heat is from the friction in your hands. Now, if you're thinking about science and careers that involve friction, think about things like engineering. Sometimes engineers want very little friction. So if you're thinking about roller coasters or moving parts on machines, you do not want a lot of friction. We don't want those parts rubbing together and wearing down. On the other hand, sometimes you do need friction. So if you have a car, you want those tires and wheels to have enough friction to be able to move along your roads. So next, I'm going to move these aside and we are going to think about something similar to our first law of motion. And so, like I said, that is an object at rest, staying at rest. So I'm going to build myself a tower here. First, I have a beaker. So this is just a glass cylinder. And you might notice that I have some water in this beaker. That's going to be important in a moment. Now, sometimes I get bored. So I like to see what I can build. So here's a pie tin. And I guess I also have a paper towel too. So what would look better on here? I'm thinking maybe I should take one of my eggs. Now, this is a raw egg, so I better be careful with it. I'm gonna stack it here. And now, I don't think I want this pie tin anymore, so I'm gonna try to get rid of the pie tin. So I want you focused on the egg. And on the egg, let's see what happens when I remove this pie tin. So we're gonna try in 3, 2, 1. And there we go. We ended up with our egg in our beaker. So this egg was an object at rest. The downward force of gravity, which pulls us to the earth, was pulling the egg down. But I had this cardboard tube, and it was pushing the egg back up. So we had equal forces. But as soon as I hit this pie tin away, this went with it. So we no longer had something holding the egg up, and it went into the beaker. So this relates to forces also, because sometimes you want things not to break or to not hit things super hard. So maybe think about when you're driving in your car. So when I'm in my car, I don't want to be hurt if I get in a car crash. So I have certain things like seat belts and airbags, and those things are going to keep me safe. Now, next, I am going to take a quick moment to clean up my surface. See, I was prepared because I am a science teacher. And this table is getting nice and clean. I have now 2 different objects here. Now, one of them you might recognize. This is a baseball. So you probably have felt a baseball before. You know that it's not easily squished. My second object is made out of foam. So this object, I can really squish and condense. Both of these have different densities. So there is more matter or more stuff in this ball than there is in this ball. So we talked about Newton and his first law. His second law of motion has to do with how objects move when you put a force on them. So when you put the same force on 2 different objects, then they're going to move differently based on their mass. So I have my handy dandy straw right here. I am going to use the air from the straw to blow on both of these objects, and we're going to see what happens. So 1, 2, 3. I wonder if you could have guessed that that would happen, because we had this object that had way more mass, it was way more dense, so that force of the air couldn't really move it. Now, when we're thinking density, sometimes in engineering, you want things to be super dense and strong, but other times you want things not to be very dense. So think about making a material, if you're a materials engineer, that would float. You might want to make it not very dense. On the other hand, if you're making something that you want to sink so it doesn't float, you'll want it much more dense. Now, for Newton's third law, this is going to have to do with opposite forces. So just like we saw with the egg and the paper towel tube, we had the upward force of the paper towel tube and the downward force of gravity. Now those were equal until we removed the paper towel tube. Now we're going to try something kind of related and we'll see what happens. So for this demonstration, I have some handy dandy ring stands. Now, if you ever take a chemistry class, you'll probably see these because we use these a lot in chemistry. Okay, so I have two rings. I do have a string between them with a straw attached. So let's spread these out in order to see what happens to this straw when we attach a balloon. I'm gonna just move this a little bit. So you can see I have my string and I have a straw on the string. Now I'm going to blow up a balloon and I'm going to attach it to the straw. And when I let go, we're gonna see what happens to that balloon. So I've got my balloon, I've got some tape. Let's see what happens. My balloon is giving me issues. Okay, so I have a balloon here. And you know, when we blow up a balloon with just our breath, it contains normal air. So it is not going to float away like if we used something like helium. So I'm gonna attach my tape. We're gonna stick this to the straw. Now take a moment and make a guess. What do you think is going to happen when I let go of the balloon? Okay, let's try. 3, 2, 1. So that balloon moved, and it seemed to move on its own. That's because when it was over here, it had a force when I let go. The air was pushing out to one side. And then, like Newton's third law, the balloon had an equal and opposite reaction that caused it to move forward. This experiment is called the balloon rocket. And this same idea of Newton's third law is important in rockets. So in rockets, we have fuel. If you're interested in how we can get the best fuel or the best gasoline for cars and rockets, maybe you're interested in being a chemist or a chemical engineer. If you're more interested in the rocket itself, maybe you can be a rocket scientist, also known as an aerospace engineer. So we've got a rocket normally, and when we want to shoot that rocket into space, we ignite the fuel, and the fuel, once it is ignited, has a downward force. That downward force of the fuel has an equal and opposite force, just like our balloon, that pushes the rocket upwards into space. So remember, we went over Newton's 3 laws of motion. His first law was about objects at rest staying at rest. This is also called the law of inertia. Then we talked about his second law, which has to do with the force on objects relating to their mass and how fast they're moving, or acceleration. And lastly, we talked about Newton's third law, where for every action in one direction, we have an equal and opposite reaction. So remember, science is all around us in simple things such as your car being able to move on a road or your airbags protecting you, even in the roller coasters and in your cell phones. So think over the next few days, every time you see something, how does this relate to science? How does this relate to engineering or people who build things? And maybe something will interest you and you'll decide that you will want to be an engineer or a scientist when you grow up. So thank you very much. I am going to pass it back.
All right, that was great. These were a couple demonstrations to see how science applies to our everyday, which is really cool. A lot of kids from Visalia Unified go on to do great things with science, which brings us to our next treat of the night. I'd like to introduce Ryan Chung. Ryan was a student of mine at Mount Whitney. He went on to UCLA to do his bachelor's degree in science, and then he went on to do his PhD program up in Canada. And now Ryan is in Chicago, and he's going to share what he does in the lab on a daily basis. So Ryan, here's to you.
Hi, everybody. I graduated from Mount Whitney High School in Visalia. So it's interesting seeing you guys type in your elementary school names, because I don't recognize a lot of those schools, but it just shows you how Visalia has grown. And so Mrs. Lovren, as she mentioned, was one of my guidance counselors, and she invited me just to talk about sort of what I do as a scientist, and sort of my journey from, elementary, middle school, high school, etc., to where I am now. And a lot of sort of the emotions or excitement that we sort of just discussed, I had very similar feelings, and sort of that's actually what guided me towards where I am now. And so what I want to do is I want to share my screen, because I just have a few slides and a video that will hopefully be interesting. All right, so yeah, just really briefly about me. So I, was born and raised in Visalia, so I grew up in the Central Valley. I went to Mountain View Elementary School, then to Visadero Middle School, and then I graduated from Mount Whitney in 2010. Like Mrs. Lovren just said, I did go to UCLA in Los Angeles. I graduated in 2014. This is Royce Hall. It's one of the main concert halls on campus. I actually did have an opportunity to sort of explore, different types of research. I did a visiting research stint at the University of California, Merced, which is not very far from Visalia. And then I moved to Canada. Basically, I had been in California my entire life and wanted to just experience something different. And so when I was sort of looking to do more school in chemistry to learn more than what I had learned at UCLA, I decided to move up to Vancouver. And that was another 4 years. I then, during my graduate degree, I was able to do an internship at Merck Research Laboratories. This is a chemical company in New Jersey, in Rahway. And this is actually where this photo was taken. So this is me in my lab coat and goggles, and you see some instruments in the back. And I'll actually talk to you about what I do on a day-to-day on the next few slides. And then now, as soon as I graduated from UBC, I moved to Chicago. So I moved to Chicago last December, and this is where I live now, basically. Well, not here, but somewhere in here. And this is sort of a famous landmark in Chicago. It's called the Bean. Okay, so I mentioned earlier that I'm a chemist, and we've actually kind of talked about this in terms of what chemistry is. And basically, chemistry is the study of everything around us. And as a chemist, I get to ask questions and solve problems. For example, how are things made? What are the building blocks of the objects around me? And significantly, how can I use chemistry to make the world a better place? And just as an example, I just chose one example. And I guess on a day-to-day, we get to what I call play with Legos and figure out how to put chemicals together or things together to make molecules, which are actually the components of everything around us. So just as an example of chemistry in real life, here I'm just putting up a diagram or a picture of a chemical called oxytocin. This is also called the love hormone. And what's nice about this is that if you have a bond with somebody, if you are friends with people or you love people, let's say your family, you will actually release this hormone within your body. What's also really cute is that if you have a bond with your dogs or with your pets, dogs specifically, the dog will also release this hormone. So it's a sort of a marker for affection and sort of familiarity that is important for us to study. And I think is in sort of a representation of what I do, we try and figure out how do we take smaller building blocks, smaller chemical building blocks, and build them up into these larger entities. And so I guess as a very brief summary of what I do, I thought I would show a video. This is actually some work out of my graduate lab in Vancouver. And what you'll see here is my colleague, Veronica, and showing sort of the things that we did to sort of streamline chemical research. And the short answer for what I do on a day-to-day is I make molecules using robots. And so let's see if this plays.
The Hein Lab is taking the next big step in lab automation. We've been developing a diverse set of automation tools to help safely streamline chemistry research before you even step foot into a laboratory. Whether it's off-the-shelf hardware or custom robotics, we extend our hardware and software ecosystem to support voice interactivity and control, from dispensing liquids and solids to operating pumps, hot plates, and analytical equipment.
Hey Siri, let's run my amine experiment.
Sounds good. I'll start setting things up for you. And while you're at work, our software integrates right into your workflow, keeping you connected to your lab status, checking for instrument errors, analyzing reactions, and updating inventory data regularly. Our system also improves accessibility for educational environments, enabling contactless teaching labs. You can use it to automatically and remotely start or stop certain processes and monitor video feeds. And for additional safety, we've added geofencing features to trigger safety checks when you enter or leave the lab. We're constantly updating our systems to complete even more challenging tasks, while integrating machine learning to improve efficiency and advance problem solving in the lab. Follow our journey and development into the world of autonomous laboratories at heinlab.com.
Alrighty. Oops. All right. So hopefully you guys enjoyed that. And so just, my time here is just really short and deliberately, and I just wanted to give some closing remarks just to sort of, sort of inspire you, or maybe just sort of plant a seed in your guys' minds for, when you're looking at what you guys want to do later on in life. And, these are sort of the concepts that I probably didn't know at the time, but sort of learned as I went through things. And so, take these as in whatever way you will. But to me, I think the best thing that you can do for yourself in terms of going and preparing yourself for the next step is to first follow your curiosity and keep asking why. Find something that excites you and keep doing it. I got into chemistry because I had a really good chemistry teacher at Mount Whitney High School, and that actually just started me down this path where I found things that were more and more interesting and more exciting, that it just kept me wanting to do it more. Don't be afraid to do something different and set yourself apart. And well, this is more relevant when we're not in COVID, but explore as much as possible. So I've been lucky to have been to many places in the US. I'd love to go to more, but we'll see when that will happen. But thanks for your time. I will stick around to the end if you guys have questions.
Elementary edition will be on Thursday, December 10th. The newsletter is going out at the end of this week. You can go ahead and register for the event and join us again in December. I want to thank you for joining us tonight. And we just really want to introduce how fun science can be and the great careers that come out of science.